All right, so we're going to focus in today solving exponential equations, day 1. To solve these equations graphically, you're going to need a graphing calculator, and since not everybody owns a graphing calculator, we're going to focus on solving them algebraically. And not only that, but graphically is not always the best way because it gives you an approximate and not always an exact value, especially when numbers don't come out to be nice, neat, whole numbers. So, moving on, we're going to solve the equations. We're going to give the exact solution, and then we're going to use our calculators to give an approximate solution to 3 decimal places. We are not going to graph them, but we will use the functions of a calculator to give a decimal approximation. So in this case, I want to get the e values. It's very important before you start solving. You have to get this e value by itself. That means I have to get rid of the 5. The 5 is connected to the e by multiplication. So we're going to divide it out on both sides to keep your scale balanced and to keep that balance of an equation going. Whatever you do to one side, you must do to the other. So on the left side, we get 2. On the right, we simply get e to the 4x. Now, opposite of e and the inverse of e, and to undo the e. Just like when we undid the square root, we squared things. When we undid squaring, we square rooted it. When we undid the cube, we cube rooted it. So here, to undo e, we have to take the natural log of both sides. So natural log is written as ln, and that's going to cancel these out. But before it cancels out, much like the log, it allows our exponent to pop out here to the front. So now I have the natural log of 2 equals 4 times x times the natural log of e. The natural log and the e value, they cancel each other. They go bye-bye. It's essentially 1. To get x by itself from here, because I have the natural log of 2 equals 4 times x, since it's multiplication, to undo it, I divide. And I get x equals the natural log of 2 divided by 4. This is my exact. I cannot reduce the 2 and the 4 because this is the natural log of 2, not just 2. I can't reduce this anymore. This is the exact solution. Now it asks me for a decimal approximate. If you find the ln button on your calculator, and it is there, and you push into ln, you get 0.639 approximately to 3 decimals. You're going to divide that by 4. So that x ends up being approximately to 3 decimals, 0.173. And you've estimated it. So again, this is your exact. This is your decimal approximation. So we're going to look at another example real quick. Something that has a little bit more to it. 5 to the x minus 4 equals 7. So looking at this, again, I want to get the 5 to the x by itself before I can do anything. So I have to get rid of that 4. It says minus 4, so to get rid of it, I do the opposite. I'm going to add the 4 both sides. I get 5 to the x equals 11. Now, this is an e. This is an exponent, so we take the log of both sides. Whenever we see an e, we do the natural log. We don't have an e. We're getting a variable out of the exponent. We're going to take the log of both sides. That allows this variable here to come to the front. So now I have x times the log of 5 equals the log of 11. It's one of our properties of logs that allows us to do this. So now we can solve both sides for x by dividing by the log of 5. So x equals the log 11 divided by the log of 5. Now, this is your exact answer. To find your decimal, you need to punch this into your calculator. And for the log of 11, you get 1.041. The log of 5, you're going to get 0.699. And to 3 decimals, that's approximately 1.490. So we're going to be practicing these in class. You'll get the hang of them.